Hello and welcome to Maths with El Profe Lo. In this video we'll be doing a little bit of work with Legendre symbols, and once again to remind, our definition is that if P is an odd prime number and if A is an integer where P does not divide A, then the Legendre symbol denoted with this A in a vinculum P, right, is evaluated as, right, that the Legendre symbol of A modulo P equals 1 if A is a quadratic residue modulo P, and it equals -1 if A is a quadratic non-residue modulo P. Okay? So in previous videos we talked about Euler's criterion. Here we're going to use Gauss's lemma. And Gauss's lemma says that when those conditions for the Legendre symbol are true, or when they're met, so you have P as an odd prime number and A as an integer where P does not divide A, then the Legendre symbol, right, this Legendre symbol of A modulo P will be equal to -1 raised to the nth power, where n is the number of least positive residues of the integers a, 2a, 3a, going all the way to p minus 1 over 2 times a, that are greater than p over 12. Okay? And we're going to show you how to use your calculator to kind of make sense of this, because Gauss's lemma is not necessarily intuitive, and you may not quite understand what n represents. So let's go ahead and do our first practice problem and look at Gauss's lemma to evaluate the Legendre symbols 11 modulo 23 and 16 modulo 23. Okay, so what does Gauss's lemma tells us? Gauss's lemma tells us that we need to figure out, right, if I want to figure out the Legendre symbol of 11 modulo 23, this is going to be equal to -1 raised to the nth power, where n is the number of least positive residues modulo 23 that are greater than 23 over 2, which is 11.5. Okay? Now, an easy way of computing this is actually going to be with our calculator, right? So in other words, what we're going to be saying is that we're going to be looking for 11a is congruent to x modulo 23, right? So we're going to be saying, hey, if I have 11a is congruent to x modulo 23, where a is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, because there are 11 numbers. There are 11 numbers that I can multiply to, right, this 11 here. So maybe I should have said 11c so that we don't make a confusion on what's representing the a. So where I have a is 11, so we'll let a be equal to 11, and times some number is going to be x mod 23. We're going to want x to be greater than 11.5. Okay? Now, it really is a lot simpler if you think about what this represents on the calculator. On the calculator, what I could come in here and say is, hey, 11 times a number divided by 23, okay? And if I look at my table of values, I'm looking for, going from 1 to 11, right? So half of the digits, or one less than half of the positive integers less than 23. Right? I look at 1 through 11, and I'm going to see how many of these decimals are greater than 0.5. Well, that would be 1, 2, 3, 4, 5. Right? So in this situation, we're going to have negative 1 to the 5th power, which is going to be negative 1. So the Legendre symbol of 11, right, modulo 23, is negative 1. And of course, in a previous video, we solved this using a slightly different approach, right, where we said, hey, if I considered 11 times each of these numbers, then how many of those left a remainder that was greater than 23 over 2? And those that had a remainder greater than 23 over 2 were when I multiplied by 2, right? Because if I have 11 times 2, that's 22. Well, that remainder is greater than 11.5. 11 times 4 is 44, and that remainder is greater than 11.5. Right? 11 times 6 is 66. Right, and that remainder on division by 23 will be greater than 11.5, and that's essentially what we're going through and doing. Okay, so if I then wanted to find the Legendre symbol of 16 and negative 23, what I would have be able to do is come in here and say, hey, y equals 16x over 23. Go back to my table. 16x is this first one, right? And I'm going to look at these first 11 pieces and see how many times is this decimal greater than half. Okay, well, let's see here. There's one at 0.6957. No, no. There's my second one. No, no. There's my third one. There's my fourth one. No. There's my fifth one. And there's my sixth one. So I'm going to have negative 1 to the 6th power, which means, whoops, not equal to 6, which means that my Legendre symbol would equal 1. Okay, so what is that telling us? That's telling us that 11 is a quadratic non-residue modulo 23, but 16 is a quadratic residue modulo 23. Okay, so this is a fairly straightforward, a little bit more rapid approach for evaluating this Legendre symbol. And we showed you how you could use your calculator to get those computations down. All right, to be able to say, hey, if I'm going to have a remainder greater than 11.5, this decimal is going to need to be greater than 0.5. And that's all we're really doing through here, is going through and counting. Okay. In our next video, we will show how to use Gauss's lemma to evaluate the Legendre symbols if I have these negatives. Okay. This has been Mass with El Profelo. I thank you very much for your time.